All right, so like Kevin said, I'm Richard Belleville. I'm a maintainer on the gRPC project. And last year, I got on this stage at gRPC Conf to look back at gRPC's first decade. This year, I'm excited to be up on stage to give you a glimpse into gRPC's second decade. So this will more or less be gRPC's roadmap, the list of features and projects we have planned for gRPC in the coming year and beyond. There's both continuity in these projects, the continuation of past trends, and things that are completely new. So before we jump into that laundry list, let's take a look at the themes driving the gRPC project forward into the future. You'll see three main pillars in this roadmap. The first should be no surprise if you've been to any gRPC Conf or even any talk on gRPC in the past 5 years, service mesh. In 2019, we decided to set out on the long journey of creating a service mesh without sidecar proxies. We did our GA launch in 2020 and haven't looked back since. New feature requests have just kept on coming in since then. And that trend did not stop this year. Just about every feature I'm going to mention today is related to service mesh in one way or another. The second is observability. gRPC went all in on OpenTelemetry a couple of years ago, making it easy for gRPC users to collect and export logs, metrics, and traces. That journey is not complete yet, and so you'll see a number of improvements we're making in the OpenTelemetry space. Finally, modernization. The world moves fast, and it'll leave you behind if you don't keep up with it. This is true for every language that we support, and for new languages rising in popularity. So some of our most exciting projects come from this modernization pillar. So with these three pillars in mind, let's dive right into the roadmap. We'll kick things off with a pair of killer proxyless service mesh features, extproc and extauthz. extproc is about modifying incoming requests and outgoing responses on a server, similar to gRPC interceptors, while extauthz is about determining whether incoming requests are authorized. Both of these features use an interesting plugin mechanism. While interceptors need to be compiled directly into your server, both of these features work based on a gRPC callout model where the server calls out to a pre-configured gRPC server in order to fill the feature's functionality. So for extproc, request and response modification can be performed by a separate gRPC server, possibly co-located with the server or possibly centralized, rather than compiling in an extension. If you're a platform team, this is a dream come true. The power of gRPC interceptors will now be available to you to enforce things across your entire system. All you need to do is deploy an extproc server and configure your service mesh to point at it. extauthz works very similarly. Each incoming request will result in an outgoing request from the application server to a pre-configured gRPC server, which will answer the question, is the sender authorized to make this request? This new plugin model will offer you new levels of flexibility in building your systems. This feature is still in the design phase, so be on the lookout for a gRFC laying out the details later this year. So next up, HTTP Connect. HTTP Connect is a special HTTP verb that turns an HTTP connection into a tunnel for a TCP connection, allowing various protocols such as SSH, FTP, or gRPC to tunnel over that HTTP connection. This is useful in two main ways. First, with forward proxies, so enabling egress from a network environment that otherwise disables egress. Second, with reverse proxies, enabling ingress into a network where ingress is otherwise restricted. You could, for example, use HTTP Connect with a reverse proxy to individually contact servers deployed to a public cloud from an on-prem environment when those servers are otherwise not accessible from the public internet. Now, gRPC has had support for tunneling through HTTP Connect proxies since 2017. In fact, this functionality was defined in the very first gRFC, A1. But now we're making this functionality dead simple to use and integrating it with service mesh functionality. Previously, HTTP Connect-based proxies were statically configured in a per-language way. Now we plan to extend the support by integrating with XDS. The control plane will be able to send down configuration instructing clients to connect to certain servers using an HTTP Connect proxy. We've already seen users of early versions of this feature take advantage of it to create a single service mesh across their on-prem and cloud environments. Super exciting stuff. Be on the lookout for this to be released cross-language later this year. Next up is support for multiple SPIFFE trust domains. As a brief intro, SPIFFE is a system for assigning cryptographic identities to individual workloads, whether those workloads are virtual machines, Kubernetes workloads, or anything else, and verifying those identities. These cryptographic identities can then be used to establish MTLS connections between workloads. And for those of you who have set up MTLS manually before, you know it's a huge hassle. gRPC has supported configuring SPIFFE-based MTLS via XDS since 2021, but only via CA files, certificate authority files. We're now adding support for SPIFFE trust bundles. This will allow you to take advantage of multiple SPIFFE trust domains. This is useful in a bunch of different scenarios. You might, for example, have a separate root of trust for dev, staging, and prod environments. This is useful to ensure that less secure environments like staging cannot accidentally access prod. Or each product area within your company might handle its own identity management. In this case, clients will still be able to interact with both workloads within the same trust domain and workloads from other trust domains. So you can expect this to land in C++, Go, and Java this year. Next up is the next iteration of a long-standing gRPC debugging utility, ChannelZ. ChannelZ gives you detailed information about the various gRPC-related resources in your process, like channels, subchannels, and sockets. Imagine flapping network connections, faulty routers, and laggy WANs. ChannelZ is a great way to troubleshoot issues like those. We now have a design for ChannelZ v2, which will be more flexible than the original version. While the original version encoded the relationships between resources like channels, subchannels, and sockets, ChannelZ v2 is designed from the ground up to be generic, allowing significant room for individual implementations to export relevant, unique details via ChannelZ. For example, certain transports have multiple TCP sockets per subchannel. Unique details like this can now be exposed and debugged more effectively. ChannelZ v2 will also allow us, the gRPC team, to evolve the gRPC resource hierarchy over time without having to modify the ChannelZ protocol to match. In short, ChannelZ v2 will make debugging gRPC applications faster and more flexible than ever. The first implementation will be coming to C++ later this year. gRPC Proxyless has had experimental support within Istio since 2021, but we're making some changes to make Istio and Proxyless gRPC an even more natural fit. Up to this point, Istio integration has relied on an insecure connection to the Istio agent, which acts as a control plane proxy co-located with the gRPC workload. We're making a couple of targeted changes to make this proxy completely unnecessary. Without this proxy, Istio and Proxyless gRPC will be an even more natural combination than before. I mentioned earlier that service mesh and observability are two of our strongest pillars, and the intersection of these two spaces is just as hot. We're adding OpenTelemetry metrics for the weighted round-robin load balancing policy, the pick-first load balancing policy, and for XDS client, the component in the gRPC library that connects to the XDS control plane. In addition to these 12 new metrics, we're adding cross-cutting labels to indicate the XDS locality associated with the metric, roughly corresponding to a cloud zone. Originally, all gRPC OTel metrics operated on a per-call basis, but we recently introduced a framework for non-per-call metrics. For example, XDS client is used across multiple calls and even multiple channels, so the non-per-call metric framework has really enabled us to enrich the observability available to users of gRPC Proxyless Service Mesh. Together, these features will make running a service mesh with gRPC easier and more reliable than ever. Next up is XDS Global Rate Limiting, a really exciting new capability within gRPC Proxyless. Global rate limiting is great for situations where your servers may frequently be overwhelmed by requests. Most rate limiting solutions require some kind of proxy, whether it's a gateway ingress proxy or a server-side sidecar proxy. With XDS Global Rate Limiting, gRPC servers natively implement this rate limiting functionality directly in the gRPC library in conjunction with a control plane. This feature leverages the existing XDS protocol for service mesh, as well as a new RLQS protocol designed specifically for aggregating load information from servers, and asynchronously programming rate limiting policy from a globalized control plane. This means that you get the benefits of a global rate limit decision making, and also the benefits of a completely decentralized data plane. Putting this all together, you have a highly performant, globally aware system for managing high-volume software. The protocols and gRPC library implementation described here are completely open source, and a first RLQS control plane implementation will be coming to GCP Cloud Service Mesh soon. Next, serverless integrations. Service mesh operators generally don't run on just Kubernetes. Whether they like it or not, feature teams in their organization often run workloads on various serverless platforms as well, such as Google Cloud Run. Unfortunately, there historically hasn't been great interoperability between these two types of platforms for service mesh. For gRPC Proxyless Service Mesh in particular, we've seen good support for Cloud Run to GKE. In fact, Kelsey Hightower demoed exactly this when Proxyless was first introduced. But the other direction, Kubernetes to serverless, hasn't worked out nearly as well. So, with Google Cloud Run in mind, we've designed and implemented a handful of features that make this a first-class experience. First, we've added XDS host rewriting that enables the use of vanity URLs in XDS targets, something very common on serverless platforms. Next, we've added JOT token-based authorization for outgoing service mesh-mediated RPCs. And finally, MTLS auth based on SPIFFE identities. Putting all of these features together, the integration between serverless and proxyless service mesh is now truly first class. Next, we have some very interesting developments in the AI space, some of which you heard about this morning. Two protocols to enrich AI models with external data and capabilities have absolutely exploded in popularity over the past year: MCP, the Model Context Protocol, and A2A, the Agent-to-Agent Protocol. MCP gives developers the ability to enrich LLMs with the abilities of any tool you can export via an MCP server. You can imagine search, file access, or any other traditional software application. The second protocol, A2A, gives long-lived AI agents the ability to collaborate with one another in a structured non-English language. Now, A2A was built from the beginning in terms of gRPC. The protocol is fully defined in terms of protobuf. But MCP originally only worked over JSON RPC. Since then, we've gotten many requests to enable MCP over gRPC with all of gRPC's rich features. So I'm happy to announce that we'll be working with the authors to make gRPC a first-class transport for MCP. And you saw a demo of that this morning. gRPC has really established itself as a key component in the AI space, so I'm looking forward to seeing what AI applications it will enable next. And last but not least, we have the newest entry in the family of officially supported gRPC languages, Rust. Rust has become incredibly popular over the past few years with its safety by default and zero-cost abstractions. And no language is complete without first-class gRPC support. So we're working to make sure that that support is there. We're building on top of the already quite popular Tonic implementation, bringing it to parity with the other first-class languages like C++, Java, and Go. And that will mean a full XDS implementation so that you can use gRPC Rust in your proxyless service mesh deployments. We've been working directly with the author of Tonic to make sure that we deliver the best experience to both existing users of Tonic and new users of gRPC Rust. And we're expecting to release a preview of this effort soon. Our gRPC Rust team did an in-depth talk on the new library about half an hour ago. In case you missed it, you can check the video of that talk out on YouTube after the conference. So that's what we have planned for gRPC for the near future. Plenty of exciting new features across service mesh, observability, and modernization. As gRPC speeds ahead into its second decade, it shows no signs of slowing down. As always, you can keep up with the project on our website, our YouTube channel, in person at our meetups, and on the mailing list. Thanks, everyone, and enjoy the rest of the conference.